Hello, everyone, and welcome to our data analysis session. So normally what we would do is we would use Excel for our data analysis. And moving forward, we're doing a lot of programming in our courses. So there's a move to Python and using Python, and we're going to find some advantages of that for sure, and being able to easily and quickly do calculations. So this is what a data set would normally look like. So this is our labs 1 to 3. So we would be synthesizing aspirin in the first couple of labs, and we would gather data with that. We'll analyze it and get mass and yield for the second lab, but then also get melting point. We'll take some averages. We'll start to plot the data against each other. And then in lab 3, we'll do thin layer chromatography, gather some data for that. We move on to lab 4. As you can see, it's a lot of data. We go on to lab 4. We develop a calibration curve. So using all of this information right here, right up to there, pretty much we're using UV Viz to create a calibration curve or regression analysis to get a line of fit so that we can figure out this value. So all this work right here is being done like that in order to do this. And we're going to see that's where Python can come in and actually really simplify a lot of this stuff here each step of the way. And then we repeat it. So we do synthesizing aspirin, then we recrystallize it, and so we get a new set of data related to the new improved, we hope, aspirin that we've made. So the acetyl salicylic acid. So again, we've got some melting points here. We've got thin layer chromatography that we're going to do, and we redo the iron analysis on it as well with the UV Viz, a new regression fit because you always got to do a new one, and right here then coming up with our new percent mass of ASA in the sample. So really testing the purity. So lab 1 is synthesizing aspirin, lab 2, 3, and 4 is testing purity, lab 6 is recrystallizing the aspirin, hopefully to make it better, and lab 7, 8, and 9 is testing the purity again using the same methods in 2, 3, and 4. And now we're going to compare the two. So we're actually going to do t-tests, we're going to do ANOVA, a variety of things like that. But what we thought we'd introduce into this course as well is some more statistical analysis. So we're going to do average and mean, which is a descriptive statistics. We're going to introduce regression analysis. We're also going to introduce control charts and figure out how to do that. And we're also going to do scatter plots with error bars. Something that's really easy to do in Python and to visualize that using Jupyter Notebook. Okay. So what we're going to do then is we're going to take this data, and I'm going to call it historical data, and this data set here itself is specifically for 2023. So we've got all this data for 2023, and we have historical data going all the way back to 2017. So the plan is we're going to start to analyze data not just from our current year, but we're going to analyze it and compare it to previous years as well and see if there's been any changes, how has the control been on product development of our aspirin throughout the years. We can compare lab groups against different lab groups and see what kind of interesting information comes about of that. So when we're putting it together then, this is what we're going to create. So this is the newer file. So this one specifically only has the mass of the starting materials, so the salicylic acid, the acetic anhydride. This is the mass of our crude that we produce and the percent yield. So we'll be doing some statistics on this. This is the mass of crude for recrystallization. So this is lab 6. And then the mass of the yield, this is lab 7 in the past. So we're changing these labs around now for us. And then the percent recrystallized ASA. So we've got all this information here, and as you can see, historically, we're going all the way back through to 2017. So we're going to see if there's some interesting trends and some information that we can gather out of this. But before we even do our experiment, this is what you're going to work on. We're going to start looking at some of this information and try to figure out historically what should we expect from our own data and our own data sets. So when looking at the data set here, we're going to see that we're going to have some values from year to year that kind of change up. Even the decimal places here change. We can go and try to fix this in the CSV file. Note that this is a CSV file, not an Excel file. It's easier to read. Also, we got missing data. We're going to let Python deal with that. So rather than go through here and tediously try to go through 243 data points and try to figure out what to keep and what not to keep. We're going to let Python do the work for us as it pulls in data and creates data frames for us using pandas. We're going to let it do the work for us. We're also going to have it scrub for other data if we're interested, and see what types of things we can do with it. Eventually, you're going to find all the information that you require in this very first Lab 0 data analytics. So on the home page, you're going to see a Lab 0. It says data analytics. And essentially, this is going to be our repository of information on how to do the work. So this is from your very first course you took with the Python and Jupyter Notebook, Comp 10274, and we're going to review that. So I've got in the two data sets that you used during that course, and I've got the actual work for you to do. So sorry, these are the data sets here, and this is it. Note that there's no videos here yet because I'm currently working on them right now. So you're going to see a whole series of videos on how to do this work as well to hopefully make our life easier. We're going to then, from reviewing this, we're going to start to learn some new concepts. The first one is called descriptive statistics, and this is basically finding the mean, the median, and a variety of basic statistics, standard deviation. That's what this one is. So we're going to use something called the group by function. So it's a new, really easy technique to group our data compared to what we did here. And we're going to use the describe function. So the describe function is this descriptive statistics, and it's really, really easy for us to use. Hopefully it's easy. I keep saying that. Next, we're going to move into t-tests. So this is a way for us to compare things before and after. So when we do the recrystallization, we're trying to see if it actually improved purity. Also, we're going to try to use a t-test to see if we've got a melting point of a product, does that actually meet the literature value? Does it say, is it the same as a literature value or not? And we're going to use that t-test to do that. ANOVA, this is where we're going to go back and it compares three or more means, three or more data sets. And so this is where we can actually go back historically and take a look. How has this product been made over time? Has every student group done the exact same thing year after year? We're going to learn about box plots and violin plots. Box plots we've used in the past quite significantly. You'll find in the math course, the stats course, that they really like the violin plot. There's some advantages to this as well, so we'll learn how to do that in Python. Regression analysis, we're going to learn how to do, and a control chart finally. So, and this is where some process control comes into play, and we're going to learn a bit about this. And we're going to pretend that we're actually working in a manufacturing setting, producing aspirin day after day after day for historically since 2017, and we're going to create control charts based on what is the expected outcome to produce aspirin and what can we do to improve this process. Okay, so that's kind of what we're going to learn how to do with these data analytics.